All right. So, guys, this is all review from Unit 3. And this will play a big role in what we're going to be doing next. So, before we move on to our next unit, we wanted to do kind of a mini unit, mini lesson more per se, because it's only like 2 lessons on some extension stuff with quadratics. All right. So we're going into quadratic inequalities, systems of quadratics, and quadratic word problems where you actually have to solve them by hand. All right. So this is going to combine a lot of things from both Unit 3 and Unit 4. So having a good understanding of both is important. All right. So that's why I've started off with this warm up, because this is just all Unit 3 review. Okay. And a lot of this stuff will connect over to the next lesson that we're about to do. So, number 1, a parabola has one x-intercept of x equals -2. And the axis of symmetry at x equals 4, and it wants to know where the other x-intercept is. So, Reagan, can you shut the door, please? So, let's break down what we know. Guys, All right, so we have a x-intercept of -2 and the axis of symmetry of 4. What's an axis of symmetry? What's the axis of symmetry? It's the x value of the vertex, but what is it specifically?
The parabola is parallel. Like this side's
Not parallel.
when the vertex turns around.
What is it specifically? Is it a point or a line? It's a line. It's the line where everything after the vertex, it starts reflecting on itself. So, how do you think I'm going to figure out where the guys? Please stop talking, or there will be a seeing chart by tomorrow. So, if we want to find the other x-intercept, what do you think we're going to have to do? Count or find the distance between -2 and 4. So the easiest way to do that is you can just subtract them. So if I do 4 minus -2, that'll give me 6. So I'm 6 units away between -2 and 4. So how many units away do you think I'm going to have to be over here? 6 units away. So if I do 4 plus 6, what is that? 10. So that's where the other x-intercept is. So remember, axis of symmetry means that each point besides the vertex has a match on the other side of the axis of symmetry. And the way you figure it out is just like if you were doing a line of reflection, you count how many units it is away from that line. All right. Now, next one. They gave you this quadratic function. They asked you to graph it first. Now, I want to graph it using stuff that we don't pull from Desmos, using the methods that we learned back in Unit 3. All right, so first off, just given that form, what form is that? It's standard. So what value can I automatically get? Y-intercept, which is what? -8. So if I come down here, 1, 2, 3, 4, 5, 6, 7, 8, here's my y-intercept. Now, we can also get the axis of symmetry from the standard form. Who remembers how to do that? It's a formula. (b/2a). Good. So if I do (b/2a), that'll give me my axis of symmetry as well as the x value of the vertex. So that would be (2/2 times 1). So (2/2), that'll be (1). So my axis of symmetry would be right here at -1. Which also means my vertex has to be at -1. All right. Now, what about the vertex? How can I find it? Plug this value back into the formula to get the x, or the y, sorry. So this will be -1 squared plus 2 times -1 minus 8, which that would be 1 minus 2 minus 8. So that's equal to -9. So my vertex is at the point -1, -9. So right here. Now there's one last thing I can find, the x-intercepts. What's the easiest way to find the x-intercepts? What form is the easiest way to find your x-intercepts? Factor. So I can factor this because it is factorable. So if I can do that, I can do a quick big X. This will be -8, 2. What are two factors of -8 that add to 2? 4, -2. So if I go ahead and factor it, because since its a value is 1, there's a shortcut. So this will be x plus 4, x minus 2. So if I set both of these equal to 0, what would I get for my x values? -4, +2. And that's exactly where my x-intercepts are at. So it's at -4. So 1, 2, 3. Well, that's 1, 2, 3, 4. And +2. Now, I can also get the pair to my y-intercept. It's 1 away from the axis of symmetry. So if I go 1 away on the other side, there's another point. So now I have 5 points, which give me the general shape of my parabola. So guys, when in doubt, if I ever ask you to graph a parabola, those are probably the things that you would want to pull from. I get the vertex, get the y-intercept, get the x-intercepts, and you now have a parabola. Now, it then wants us to know where the interval is decreasing. So what does it mean for it to decrease? So interval of decrease, we talked about this back in unit 3. What does it mean for our graph to decrease? It's going down. Now, remember, when we're talking about intervals of decrease, we're only looking at what values? X or Y's? X's only. So our intervals are only going to contain X. So remember what I said, you always start at your top leftmost corner, and you're just going to run your pencil along the graph until you hit the vertex, because remember, that's the turning point. Hold on, it froze. All right. Then you should be going in the opposite direction after you hit the vertex. So which side of the vertex is decreasing, the left or the right? The left. So this is my interval of decrease over here. So are we using the x or y value of the vertex? We're using the x value only, which is what? -1. So another way you can think about it is use the axis of symmetry. All right. So I'm going to write this both in interval notation and in set builder notation. All right. So interval notation first. So what's my lowest x value that I start my interval of decrease at? Not -1. So my lowest would be over here. So as far left as I can get. What's as far left as I can get? Infinity, negative infinity. So this goes from negative infinity to where? Where does it end? -1. Now, do I use a parenthesis or a bracket for that? Nope. We use a parenthesis. Why? What's true about a turning point? Does it? It's neither decreasing nor increasing. So we cannot say for a fact that -1 is also decreasing. So because of that, we have to use a parenthesis. Now, if I'm talking set builder notation, that means I'm talking about x values that are what to -1? Do they have to be greater than or less than? Look at your set builder notation, or not set builder, look at your interval notation. Less than. All right, you're looking at numbers between negative infinity and -1, where -1 is your bigger number. So either one of these would work. Now, the next one is asking what is the interval for when f of x is less than 0? So in other words, we're talking about when y's are less than 0. So I'm talking about when the y values are what? If y is less than 0, that means the y values are what? Negative. So I'm talking about negative y's. So what do you think my point of reference will be? So to write these intervals, what do you think my point of reference will be? So what key feature on the graph do you think my points of reference will be? We talked about this, the x-intercepts. So the x-intercepts are your points of reference because the x-axis is where y is equal to 0. All right, so you're looking for where it's less than 0. So are you talking about above or below the x-axis? Below. So we're talking about right here. So same thing as decreasing and increasing intervals, x values only. So at what x value from left to right does this interval start? -4. And we're going to use a parenthesis because remember, it doesn't say equal to 0. All right, so we have to use parentheses. So we go from -4 to where? Where does it stop? +2. It stops at +2. Because after that, the graph is now above the x-axis, so the y values are positive. Now, set builder notation, all you would do is make a compound inequality. So your x would be between -4 and 2. So it's your x is greater than -4, but less than 2. All right, lastly, state the range. So range is what? Nope. Range is your y values. The domain would be all real numbers, but your range is your y values. So remember, you go from bottom to top. So what's my lowest y value? -9. Would I put a parenthesis or a bracket there? Bracket. This is one of the only ones that you ever use a bracket. Where does it go to? Infinity. So if I wanted to write this in set builder notation, I would say y is what to -9? Are my y values going to be greater than -9 or less than -9? Greater than or equal to -9. Because we have that bracket, so it has to be equal to -9. So guys, number 2 is really important because it's going to come back to haunt you in this next lesson. You got to understand where all these intervals come from. All right. Now, 3 and 4, these are definitely ones that you want to use Desmos for. So, a projectile is fired at an initial velocity of 86 meters per second with an initial height of 6.2 meters given by this function. So they already gave us the function, where t represents the time in seconds of the projectile fired. The projectile hits peak height at t equals 8.775 seconds. Which of the following is closest to the greatest height? So, I'm going to graph this in Desmos. Where's my mouse? So I have negative 4.9. What the? So I have negative 4.9 x squared plus, what is it, 84x? 86, yeah. Plus 6.2. All right, I'm going to remove this one. Now, I want to zoom out some so I can see what's going on. So if it says that its max height is when t is equal to 8.775, all right, we don't know for certain that that's the vertex or not. All right, it just says it's peak height. So this could be it, but what's another way we could have done that if we didn't know it was the vertex? What's the way we could have checked? We could have plugged it in, so we could have done x equals 8.775 and then find the point of intersection as well. So we could have done that. Or you could have plugged in 8.75 into x and evaluated it. So my answer is about 383 or 384. So it would be number 2. All right, last one. Physics students were modeling a height of a ball once it was dropped from a 25-story building. Of h of the ball above the ground as a function of the number of t seconds since it was dropped, given this function. So, from what height was the ball dropped? How do you know? It's your y-intercept. So remember, your y-intercept is typically your initial height. So it had to drop at 300 feet. Now, to the nearest tenth of a second, determine the time in which the ball hits the ground. So what key feature am I going to look for when I graph this? The x-intercept. Now, would it be the positive or the negative x-intercept? Positive. So, put this a quick graph into Desmos. So I have 300 minus 16 x squared. I'm looking for my positive x-intercept. So if I round that one to the nearest tenth, so if I round this x-intercept to the nearest tenth, what would that be about? So I got it clicked on the board, guys. So what would that be about to the nearest tenth? 4.3 what? Seconds. All right, so the reason we took the time to go through this is because, again, all this stuff you will see again with this mini lesson. So this lesson is going to take about 2 days, and it's going to involve solving quadratic inequalities, solving systems of quadratics with linear and quadratic functions, and solving word problems by hand. All right? So we're going to start first with inequalities. So go to the next page. So far we have learned how to solve quadratic equations. All right. So now we're going to solve quadratic inequalities. Not the main, so there's not much difference between solving quadratic equations and solving quadratic inequalities. You still solve quadratic inequality like you would quadratic equation, except your answer is going to obviously have a less than, greater than, less than, equal to, greater than, or equal to in it. All right. So first off, we're just going to look at if we can figure out if it's a solution of inequality. So the difference between an inequality and an equation is an equation has a set value. So it's either like equal to 2, equal to 3. It's either equal to a set value or a set number of values. Whereas an inequality gives you an interval of values in which makes the inequality true. All right. So first off, for exercise 1, they just want to know is this inequality true if x is equal to 4? So how do you think I'm going to check? Plug in 4 and for x. So I have 4 squared minus 3 times 4 minus 10, and I want it to be greater than 0. So what's 4 squared? What's negative 3 times 4? And then minus 10. So 16 minus 12 is 4, minus 10 is negative 6. So does it make it true? Is negative 6 greater than 0? No. So no, it's not true. Because that's not a true statement. All right, what about for letter B? So we want, given this inequality, we want to see if x equals 2 works. So we're going to plug it in for x again. So 2 times 2 squared plus 13 times 2 minus 7. We want it to be greater than or equal to 0. So what's 2 squared? Times 2? So this would be 8 plus, what's 13 times 2? 26 minus 7. So that would be 19 if you put that in your calculator. And is that greater than or equal to 0? Yep. So yes, x equals 2 is part of that solution set. So is everyone following what I'm doing so far? We're just checking to see if these are in the solution set. 26 minus 7 is 19 plus 8. Oh. You threw me off when you said 8. So this is actually 27. Anyone wants to know it's Clark's fault. All right, so last one. Take a minute, try that one on your own. So try letter C on your own. See if x equals negative 3 is part of that solution set. Guys, less talky, more worky. Also, if you haven't grabbed a TI yet or have a calculator out that's not Desmos, go ahead and grab one. You're going to need it. So if you have your numworks, that's fine. But if you need a calculator, grab one. All right, so is -3 part of the solution set? Are you guys sure? All right, so thumbs up if you say yes, thumbs down if you say no. It's yes. So, oh wait, no. No, it's not. Yeah. All right, so yeah, it is no, because this will be 12. Shh. This will be 12 minus 12, so 0 cannot be less than itself. If it had equal to, then yeah, it would be true. All right, so now let's look at how we would actually solve these inequalities. So, whenever you want to solve an inequality, the first thing you want to do is just solve it like an equation first. So this is the inequality that we want to solve. We want to solve x squared plus 2x minus 3 is going to be less than 0. Well, the first thing we want to do is just solve the equation. So if we just said x squared plus 2x minus 3 is equal to 0. All right, that'll give us an idea of where our solution set may lie. All right, so first off, this is review from Unit 4. What would be the easiest way to solve this inequality? Factoring. Now here's the question. Is this factorable? Yeah, it is. All right. So if you can't solve it by factoring, what would probably be the other method you would have to use? Quadratic formula. All right. So I will say for quadratic inequalities, most of the ones that we're going to see are factorable. So I'm going to do a quick big X. So -3 on top, 2 on the bottom. Guys, someone let him in, please. So, shh. So what are two numbers that multiply -3 added to? 3 and -1. Now, if we do a quick AC method, this would be x squared plus 3x minus x minus 3 equal to 0. All right, what's the GCF of the first group? X, so I get x plus 3. What's the GCF of the second group? -1, so I get x plus 3. So since the parentheses are the same, I get x minus 1 times x plus 3 is equal to 0. Now, since we're solving, this is where a lot of y'all lost points on those short answers yesterday. A lot of y'all factored it, but you didn't solve. All right. So, how do I solve? Set them both equal to 0 and solve those mini equations. So x would equal +1 and x would equal -3. So x is equal to the set of -3 and 1. Now, why is this important? This gives us an idea of where these will fall. All right. So what we're going to do now is, first off, we're going to fill in this table using our TI calculators. All right. Before we do that, real quick, if x is equal to -3 and 1, that means their corresponding y values are what? 0. So we can go ahead and fill those two in. So if you're using your TI, in order to make the table, because I think using a TI for a table is way easier unless you're trying to find a very specific value. All right. So you would go to y equals in the top left corner. If you have anything in there, just hit clear. And then you're going to type in the function. So you're going to hit x. So the variable key is over by that green alpha key. Square it plus 2x. How do I do what, huh? How do I square it? You either use the caret key. Top left corner. And then -3. If you're using your numworks, you would just go to the graph feature, type in the equation, and then it's really easy because as soon as you type in the equation, you just scooch on over to table. All right, is everyone here? Then you're going to hit the second key, so that blue second key, and you're going to hit the graph key, which is the top right corner key. So you got to hit second first, otherwise it'll just generate the graph. We want the table. Now, the great thing about the table and the graphing calculator is you can use your up and down keys to look at specific X values that you want. All right. Now, Desmos versus graphing calculator. Desmos is better when you're trying to find specific Y values at specific X values because you can just type it in. But if you're trying to get a list, your TI is probably your best bet. All right. So take a moment using your graphing calculator and fill in that table. All right, you guys got the table? All right, so this should be the table that you have filled in. Shh. Now, looking at this table, if I want it, if I want it to be less than 0, so your Y values have to be less than 0, where would I cut off? So -3 and 1 are kind of like you're defining, but would it be between those two numbers or on other sides of them? It'd be between them. So this right here would be where your solution set is. Now, these other numbers, why are they not part of the solution set? Because we're outside of, well, not necessarily outside, but look at the Y value specifically. So why is -4 not part of the solution set for X? So if X is equal to -4, why is that not in the solution set? Because the Y value is a number greater than 0. All right. So if I wanted to write the solution set, there's two ways you can write it. I can either write it as between -3 and 1, and we use parentheses. Why? Why am I using parentheses and not brackets? It's not equal to. All right, so since our original does not have that equal to, we have to use parentheses. Guys, I'm serious. If you keep talking, you're having a seating chart. So the other way we can write it is as a compound inequality. So we can say that X is between -3 and 1. Either way. Mm-hmm. And you may see it like if this was a multiple choice question on like a quiz or something, you probably see it either way. So you need to be familiar with both. X-intercepts.
Then do we technically even need to do all this? Or just
It depends on what's in the solution set. So the table's useful because it tells you where the solution set would be. Because let's say I said it was greater than 0. That means that it would have to be less than -3, but greater than +1. You'll see it in a second. All right, so why are the zeros you found in not part of the solution set? Because the original problem said less than 0, not less than or equal to 0. So that's why it's technically not part of our solution set. That's why we use parentheses if we write an interval notation. And we don't use equal to symbols when we write it in Set Builder. Now, if I was to draw this on a number line, I'm just going to do a simple number line. So I'm just going to put -3, +1. So this is review from Math 1. If they're not equal to those numbers, what type of circles do I draw on -3 and 1? Open. So I'm going to put open circles on these numbers. Now, if I want them between, where would I shade? Would I shade on either side of them, or would I shade between them? Between. So if I was to draw this on number line, this is what it would look like. We're saying that my solution set lies right here. So any value, whether it be decimal, fraction, whole number, whatever, rational, irrational, as long as it's between those two numbers, it's valid. So the key to solving a quadratic inequality algebraically is to first find the zeros. So in other words, solve it like an equation. Then test points between the zeros and outside the zeros to kind of see where your solution will lie. So you need to check 3 points. You need to check 1 point on either side of the solution set. So if it was this one originally, I would say 1 less than -3, 1 greater than 1. And then you need to pick a number between the two. So in other words, you would pick, your two numbers would be a number less than smallest 0, or smallest x-intercept, however you want to put it, a number between the x-intercepts, and a number greater than your larger x-intercept. All right, so 3 numbers you have to test, and then those numbers will help you figure out where your solution set actually lies. All right, so let's give some more examples a try. Are you guys good? All right, so let's look at letter A on the next page. Now, it wants it in set builder notation as well as on a number line. I want to do set builder, interval, and a number line so we can see all of it. So first things first. Actually, I want to do one that's greater than. So let's look at letter B, actually. So letter B. All right, first off, we're going to attempt to solve it by factoring. So if I do A times C real quick, all right, what's A times C? Do you think it's fairly possible to find two values of 60 that add to 28? Yeah, it's probably possible. So we'll give it a shot. So we know this will be -60. It needs to add to 28. So two values of -60 that add to 28. So let's just list some values of 60. So 1 and 60, 2 and what? And I think we got a winner right there. Because if I make one of those negative, would that add a 28? Because we want it to equal negative 60. Which one would have to be negative? The 2. This would be negative 2 and 30. So I'm then going to break this apart. So 5x squared plus 30x minus 2x minus 12. What do I factor out of the first group? 5x. What am I left with? X plus 6. What about the second group? Negative 2. I'm left with x plus 6. So this would be factored to 5x minus 2 times x plus 6. And we're solving for the x-intercept, so we're going to set it equal to 0. Now, if I set both these equal to 0 and solve, what are my two solutions? So 2/5 and negative 6 are both equal to x. So we know that our solution set, I'm just going to go ahead and start drawing my line. We know our solution set is going to be somewhere around negative 6 and 2/5. We don't know if it's between yet. We don't know if it's greater than or less than for either one. That's where we got to test our values. All right. So we are going to make a little table. All right. This is the x value we're going to plug in and the y value we get. So remember, I want three numbers. I want one number that's less than negative 6. So I need one number over here. If it helps, kind of divide these into sections. So these are the three sections that you need to get. You need a number that fits in this section, a number that fits in this section, and a number that fits in this section. All right. Now, I recommend picking nice whole numbers to plug them back into it. All right. So what would be a nice whole number that's less than negative 6? Negative 7. All right. So let's say we test negative 7. All right. So if we test negative 7, plug that into your calculator back into your original function real quick. So do 5 times negative 7 squared. Make sure you put parentheses. Plus 28x minus, or plus 28 times 7 minus 12.
Dude, you're in the y equals part or just on?
No, just you're plugging in negative 7 in for x into your original function. So in other words, guys, you're doing 5 times negative 7 squared plus 28 times negative 7 minus 12. You're going to tell me what that's equal to. So what'd y'all get? 37. All right. So next, we need a number to fit between negative 6 and 2/5. So what would be the easiest number possible? 0. If 0 falls in there, use 0. So in other words, if I plug those into x, what should I automatically get? Minus 12. In other words, your y-intercept. And then lastly, I need one more number that's greater than 2/5. 1 is definitely the easiest. So if I plug 5 times 1 squared plus 28 times 1 minus 12, what should I get? 21. So look at these numbers. Which of these three numbers fit into my solution set, meaning they are greater than 0? 37 and 21. So that means that if I was looking at my solutions, I would have solutions over here, and I would have solutions over here. So in other words, how would I write this as inequalities? So how would I state that so what's the relationship with my solution to -6? X is what to -6? Less than. Or, so if they're going in opposite directions, you use or, it's not a compound. X is what to 2/5? Greater than. Now, on my number line, will I use open or closed circles over my x-intercepts? Open. So if I wanted to use if I wanted to use interval notation, I would say that my solution set is from -infinity to -6, union, meaning it stops and then it picks up again, at 2/5 to infinity. That's your final answer. So either one of these can be considered your answer. Typically, I would want it like this. Yes. Open or close is, if you look at your original, if there's no equal to symbol underneath it, it's open. If there is, it's closed. All right, let's try one more. So let's do letter D. Now, just like with solving a quadratic equation, we always got to get one side equal to 0. So before I can even start solving for when x is equal to 0, what do I need to do first? Subtract the 14x and subtract the 19 to the other side. That goes away from both sides. This will be x squared minus 25. It's less than 0. Now, if we were to factor this, what's true about that? They're not perfect squares, but they're difference of squares. So how do I factor a difference of squares? Take the square root of both, and then what do I do with that? Nope. So my a would be x, my b would be 5. Right. So be x minus 5, x plus 5. I'm going to find it equal to 0. Thus, x should be equal to -5 and +5. So on a number line, that means we're dealing with -5 over here, 5 over here, and we need to find where it would fit in the solution set. All right, so we need to have our 3 number checks. So what's a number that's relatively less than -5? -6. So if I plug it into x squared minus 25, what's -6 squared? 36 minus 25? 11. All right. What's a number in between 0 and -5 and 5? 0 or 1. I'm going to use 0 because that's easier. Because that'll just give me what? -25. I plug it back in. And then I need a number greater than 5. 6. Still 11. Crap. So we want it to be less than 0. So which number fits that solution? The -25 is the only one that works. Thus, my solution set is where? Is it on either side or between? Between. So it would be right here. Now, would I have open or closed circles? Open. So I would write this as a compound inequality to represent this between. So I would say x, and you'd have less than symbols on either side, and then you just write in numerical order. So it would be -5 on the right, not oh Lord, -5 on the left, and 5 on the right. In interval, it would be between -5 and 5, with parentheses because it's not equal to. Mm-hmm. So, guys, another way you can figure out if it's a compound inequality, think about it. X would have to be greater than -5, and x would have to be less than 5 in order to be in the solution. Well, we could just write it very easily like this because it's basically just two inequalities in one. X is less than -5, and x is greater than 5. The reason we can't combine it like the one we did up here is because it wouldn't make sense. All right. All right. So, last one we're going to do for this part. So, here's my question. All right, if we were to factor this first, what would need to come out? So there's a GCF that needs to come out. -1 needs to come out. Now, what I say you do to get rid of that -1 when we start solving? Let's just go ahead and get rid of it now. Divide it out. Now, here's my question. What happens with an inequality when you divide by a negative? It turns the sign. So this is now 2x squared. Sorry, this should be minus and plus. Minus 7x plus 3 is less than 0. So we're not going to necessarily solve that because I can guarantee that y'all can solve that. But I just wanted to note that if you have a negative in front of your a value, take that negative out, divide it over, flip the sign. Now, if we kind of just take a gander at this. So just for time's sake, I'm going to go ahead and have this factored for you. Okay? So this would be, if I did 6 on top, -7 on bottom, I would have to have -6, -1. So, because I know y'all can factor, this would be 2x minus 1, x minus 3. So x would have to equal 1/2 and 3. So automatically, that kind of gets rid of 2 of our answer choices. So anything that does not contain those 2 numbers are gone. Now, let's just do a quick check to see which one we're going to figure out. So, on my number line, if I have 1/2 and 3, I need my 3 numbers to fit. So what's one less than, or what is a number less than 1/2? No. 0. All right, if I plug 0 back in to my, you can either plug it into your original or you can plug it into the new. I would plug it into the new. So if you plug it into the new, what would it give you? 3. So this gives us 3. All right. What about 1 in the middle? So I'm going to say 1 for this. If I plug in 1, what do you think? Is it going to give us a number less than or greater than 0? It's probably going to be less than. So 2 times 1 is 2 minus 7. That's -5 plus 3, -2. Then for this last one, let's pick 4. Plug that in real quick. 4 squared is 16 times 2 is 32 minus 28. That would be 4 plus 3 is 7. So which one is less than in the middle? Yep. Now, if we use the original, all that would happen is they would give us the same numbers, but the signs would flip. So it would still fit into this number line, regardless of which one we plugged it into. So, which would be my answer, 1 or 4? Would it be between 1/2 and 3 or on opposite sides of them? Between. So is that going to be 1 or 4? 1. Oh, that just means X is within the set of that. So that's what set builder notation truly is. They write it as X is within the set. That's how they start it, but I don't expect you guys to start. As long as you give me the inequality, I'm happy. All right. So that is inequalities. Now, let's look at systems. So we're going to at least start systems. All right. We may not get through all of it, but we're going to start it. Now, systems involve inequalities a little bit because it kind of involves more so intervals as well as solutions. So when you think system of equations, so in math 1, you dealt solely with systems of linear equations. All right. Typically, what were you looking for in a system of linear equations? Like if you were given a graph, not a slope. So when you think system of equations, what do you think of? So guys, this is review from math 1. System of equations. How many graphs would be on one graph if you graphed a system? 2 different graphs. And what would you technically look for? What would tell you your solution? A point of intersection. All right. So it's also on your paper if you read. All right. So to solve a system of equation means you're finding all the points of intersection of the 2 relationships. All right. So with systems of equations, there are a couple of different methods that you guys learn. You learned substitution, you learned graphing, and you learned elimination. Really, when you're solving quadratic linear, you either use substitution or you use graphing. You can't really use elimination. All right. So we're first going to start by solving it algebraically before we graph. So here are my 2 equations. Now, I think substitution is going to be the easiest because do you see how both of them are equal to y? So if they're both equal to y, how can I set this up? You can just set them equal to each other. We can cut out the middleman. So I'm going to set this up as 3x squared minus 8x plus 5 equal to 4x plus 5. Well, we know how to deal with that. Doesn't that just look like if we're trying to solve a normal quadratic? Yeah. So what do you think we're going to do first? Subtract the 4x and subtract the 5 to both sides. That goes away. I get 3x squared minus 12x, and then that cancels is equal to 0. Well, ooh, that's an easy factor. Because what's the only thing we can factor out? A 3x. It has a GCF of 3x. Factor that out. I'm left with what? X minus 4 equals 0. Now, this is also where a lot of y'all went wrong on your test yesterday. What did I say about GCFs? You can only get rid of them if they are what? Strictly what? Nope. So when you're solving, you can only ignore the GCF if it does not have a what? Variable. But if it does have a variable, what do you have to do with it? Set it equal to 0 and solve it. So 3x equal to 0, x minus 4 equal to 0. So x has to equal to 0, x has to equal to 4. Now, those are just the x values. How do I get the y's, you think? Plug them into one of the functions and then solve for y. So I recommend the linear one because it's easier. All right. So if I do 4 times 0 plus 5, that'll just be 5. So this would be at the point 0, 5. That's one of our solutions. And then 4 times 4 plus 5, that's 16 plus 5, which is 21. So 421 is our other solution. So if we wanted to write this, we would say xy is equal to 0, 5 and 421. Now, let's do a quick graph of this. So I'm going to graph the linear first because that's definitely easier. So if I do that, we know my y-intercept is 5. What's my rise over run? So what's my slope? 4. So my rise over run will be what? 4 over 1. So up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. I'm just going to keep doing that till I get to at least y equals 21. So up 1, 2, 3, 4 over 1. And then this will be the last one. And then we got ourselves a line. Now, what's the y-intercept of the first? So what's the y-intercept of the quadratic? 5. So I'm going to put quadratic, it has a 5. All right. If you did a quick negative b over 2a, what would the axis of symmetry be? So if I did negative 8 times a negative over 2 times 3. Well, it's not a nice number, but another way we can do this is let's just use Desmos, get a quick table. So if I plug in 3x squared minus, what is it, 14x?
Okay.
12x. That's not right. Guys, the original quadratic. 8x plus 5. All right. Zoom in a little bit. Ugly vertex, less ugly x-intercepts. All right. So we can just guess and check a little bit. All right. So our vertex is around between 1 and 2, and it's about close to negative 1. So our vertex would be somewhere about right here. Nope. Our vertex would be somewhere about right here. Then we have a y-intercept here, y-intercept here. And then we know at some point it intersects here as well. So this would be our other graph. Now we're going to check these intersection points. So I already have the first graph graphed in Desmos. Now I need to put in the second one. So 4x plus 5. I'm going to zoom out a little bit. We're going to check its points of intersection. So that'll be here and here. Is that not exactly what we got? Yep. So more often than not, systems are actually pretty easy between a quadratic and a linear. You just set them equal to each other and then solve for x and then just plug them back into one of them to get the y. So the only difference is that you have to get a y value as well. So you have to plug your x value back in, or x values.
Does it matter which one you plug into?
No, you could have plugged it into the quadratic. I plugged it into the linear because it's easier. Rule of thumb is plug into the one that looks easier. But it doesn't matter which one. All right. Let's do one more and then call it a day. So, the last one we're going to do is this one right here. Now, inequalities, a system of inequalities, you also did these in Math 1. Remember, with a system of inequalities, the only thing that differs from a system of equations and inequality is that it's the shading. So it's where the shading will overlap. All right. So I'm going to do this entirely by graphing. So I'm going to graph both of these and sketch the graphs. So in Desmos, I'm going to type in y is y is son of a biscuit greater than negative 2/3 x plus 8. All right. So I'm just going to go ahead and sketch that line. So I'm going to get some points. So I have an x-intercept at negative 8, y-intercept at 12, 0. So x-intercept at 8. And then I can just do some rise over run. So down 2 over y-intercept. You know what? It's already a Tuesday. It's fine. Down 2 over 1, 2, 3. And that's good enough for me. Now, since it's less than and not less than or equal to or greater than or whatever. All right. Would my line be dashed or solid? Dashed. So when you draw this, draw it as a dashed line. Now, we're talking about values where it's greater. So think about it this way. If you had a line going like this, would you shade above or below it if you're talking about greater than? Above. So we would shade right here because it doesn't have an equal to. It's solid if it's an equal to. It just means any point on that line is not part of the solution. All right. The other one. Is right here. So that'll be y is greater than or equal to x squared minus 10x plus 23. So first off, I want to mark all the points of intersection. So that'll be at ugly numbers. Did I plug that in right? Yeah, I plugged that in right. Just ugly numbers. Okay, that's okay. Because we're rounding anyway. So if I want to do a quick graphing, let's do vertex is at 5, negative 2. So vertex is at 5, -2, so right here. And then it intersects at around 2.1 and so 2.1, 6.6, and 7.2, 3.2. So 2.1, 6.6, about right here. 2 point, whatever, close enough. And then 7, and then 3, so about right here. Now, the shading, if I'm talking about greater than or equal to, all right? And you can also just look at the shading on your Desmos. Where did it shade? It's shade inside or outside? Inside. So that's why we do it by graphing. So if they shade it inside, it's right here. So remember, your solution set is the points of intersection, and it's where the shading overlaps. All right. So this right here is your where the shading overlaps. Now, would that be between your 2 points of intersect or outside of your points of intersect? Between. So, all right. That means that XY would have to be less than or equal to, all right, these 2 points. So that'll be 2.1, 6.6, and 7.3, 3.2. All right. No, it's usually nicer numbers, but this one I just pulled from somewhere, so it just wasn't nice numbers. All right, we'll go through more of this tomorrow. Your homework for tonight is page. I want you guys to do all of page 8 and 9. So just the quadratic inequalities homework. So page 8 and page 9. And let's also do. Let's also do page 10. So page 8 through 10. That's fine. I'll be perfectly honest. It ain't gonna get great today anyway. So I got like a mountain to grade right now, so it's